Hello everyone, welcome back to another video. In this video, we are going to discuss a topic from advanced AI/ML, that is about artificial neural networks. So let us get into the presentation without any delay to learn more about this. So let us see what are artificial neurons. So basically, these are building blocks of your neural networks which have input signals and activation functions. So artificial neurons receive input signals from previous layers or external sources, just like how neurons receive from other neurons, and these inputs are weighted and they represent their importance in calculations of activation function. So activation function is basically determines the neuron's output based on the weighted sum that is present on the neuron, and it is allows network to learn various complex relationships patterns between present in the underlying data, huge amount of data. So next, so let us see about the activation function. So basically there are three. The first one is sigmoid, then we have the ReLU function, then we have tanh function. So sigmoid, it is basically a function that squashes the weighted sum of the inputs into a range between 0 to 1. So anything above 0 is not possible, and less than 0 is not possible. Hence it is commonly used in binary classification tasks, like in the form of like true or false, yes or no, present, not present, etc. Then in ReLU, basically it stands for rectified linear unit, and it inputs directly if it's positive, and 0 if it's negative. And it is used for simplifying calculations and improving the efficiency of the neural network. Then tanh, basically it's a hyperbolic tangent. It is similar to sigmoid, but it outputs the value between -1 to 1. There it sigmoid outputs the value 0 to 1. Here it outputs the value -1 to 1, and it's basically used for handling negative value efficiently. So next we have the characteristics of artificial neural network. So basically the first characteristic is adaptive learning. Then we have nonlinearity. Then we have hierarchical structure. Then we have parallel processing. In adaptive learning, the neural network it itself learns based on the training data by adjusting the weighted sum, and that is present on various neurons, and it allows them to improve their accuracy and performance over a period of time. Then in non-linearity, it introduces non-linearity, where the model helps in understanding complex relationships in the data, like traditional linear models. And in hierarchical structures, neural networks are organized in the form of layers. So each layer extracting different features on the previous layer, and hierarchical structure allows for learning increasingly complex patterns present in the data. Then in parallel preprocessing, neurons can operate concurrently one after the other by speeding up the computation and enabling efficient handling of large amount of data processing at a particular time. Then let us see what is feed forward versus recurrent neural network. Feed forward network, in this network the information flows in one direction from input to output layer without any feedback loops. They excel in tasks like classification and regression tasks. Then recurrent neural networks, basically these have feedback loops that it allows both bidirectional flow of information. This enables them to process sequences of data such as text, speech, images, etc. Then we have convolutional neural network. It is basically used for convolutional filters, pooling layers, and classification. They slide over the input images and extract features like edges, shapes, texture. These can be filtered and recognize and help in recognizing various patterns that is underlying in the data or presented in data. The downsample feature maps, it reduces the dimensionality of data, making the network more efficient and improving the features. Then classification, basically used for segregation and extracting features, predicting categories or labels of input images. The next, collaborative filtering. So it is basically it is basically used for making personalized recommendations. Basically these, you can observe these kind of things in mainly in online platforms like Netflix, etc., which take your data, users' preferences, and perform some calculations, filter out the various choices or tastes of various humans, and further they go and suggest you various things. So collaborative filtering is used here. So the first one is user preferences. The system basically gathers users preferences and various rating for items. For example, let us consider you have booked a water bottle based on the ratings and you have rated it. So based on the particular ratings and the particular category of water bottles, the website or online commerce website is going to suggest you with the similar kind of things such as water bottles, etc. So it's basically uh, used for understanding individual tastes and individual choices. Then we have similarity calculation. Then the system calculates, identifies the user's preferences, and based on their ratings it searches for other items which have similarity, almost similarity of maybe views or size or the category, that is bottles, etc. And it, based on their rating, it again recommends you with the similar kind of objects or things that you like. Then recommendation generation, basically based on the similarities that have been identified in the second step, the system predicts the likelihood of a user liking the particular item that it has found or discovered in the similarity calculation. Then the algorithm then recommends items that are likely to be purchased or enjoyed by the user. So next, here let's see about unsupervised learning. Basically, it is discovering the hidden paths in the data. So first we need to explore the data. So these algorithms analyze unlabeled data to uncover underlying patterns and structures. So these allow for insights into data without prior knowledge and of its category or labels. That is, you have no idea about the data and various underlying patterns in the data. So you need to explore the data in order to know the underlying patterns and structures of data. Then pattern discovery, various algorithms like clustering and association rule learning algorithms help in identifying hidden relationships in the data and helps in revealing valuable insights or informations about the characteristics of data or categories of labels that are present in the data. The next we have knowledge extraction. The extracted patterns can be used to segment customers. For example, based on the underlying patterns that are learned, we can able to detect anomalies, like identify some relationships that are present in data, and also make carry out various decisions based on the patterns that have been understood. So that's it for the video. I hope you learned about artificial neural network and collaborative filtering and a difference between concurrent and recurrent neural network, then unsupervised learning. So that's it for the video. Thank you.